Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on January 26, 2026, so just about 6 days ago. It introduces a new framework for speech alignment that achieves a massive 69 to 78% reduction in accumulated timing errors compared to prior methods. The paper is titled LLM-ForcedAligner, a non-autoregressive and accurate LLM-based forced aligner for multilingual and long-form speech. And as we'll see shortly, the results are really striking, especially when it comes to keeping long audio recordings perfectly in sync. Alright, Figure 1 illustrates the core mechanism. The model takes two inputs, the audio waveform on the left and a transcript with special empty time slots on the right. It then processes everything at once to fill those slots with precise start and end timestamps, like the values you see for hello and world at the top. This non-autoregressive approach enables the key benefits listed below, such as handling long recordings up to 300 seconds and supporting 10 languages within a single model. Well, Figure 2 details the exact training and inference pipelines that make this possible. On the left, during training, the authors employ a dynamic slot insertion strategy, which randomly determines whether to include or ignore timestamp slots for each word. This forces the model to learn robust dependencies without relying on a rigid structure. Crucially, the cross-entropy loss is computed only at the specific positions of these retained slots, shown as the green squares at the top. Then on the right, for inference, the system switches to non-autoregressive decoding. This means it predicts all timestamp indices simultaneously, drastically improving speed and preventing the hallucinated drifts common in traditional methods. So with the architecture defined, Table 1 presents the main quantitative results using the accumulated averaging shift metric, where lower numbers indicate better synchronization. The central columns compare the new model against baselines like monotonic aligner, NFA, and WhisperX across 10 different languages. Focusing on the rightmost column, LLM-ForcedAligner consistently achieves the lowest shift errors, keeping most values under 50 milliseconds. In fact, looking at the average row at the bottom, the error drops from around 130 milliseconds in prior methods down to just 43 milliseconds here. Alright, Table 2 shifts the focus to long-form speech, specifically recordings up to 300 seconds long. This setting is notoriously difficult because timing errors often accumulate, leading to massive drift in traditional models. Notice the WhisperX column in the middle, where errors for languages like French and Italian skyrocket to over 2,000 and 5,000 milliseconds, effectively losing sync by several seconds. In sharp contrast, the LLM-ForcedAligner column on the far right remains stable. It keeps the average error down to just 53 milliseconds, proving that its non-autoregressive design eliminates the cumulative shifts that break other systems. While the previous results relied on automated labels, Table 3 now validates performance against ground truth human annotations. The rows cover challenging scenarios, like noisy speech and long-form concatenations. Looking at the mixed 300s row is revealing the monotonic aligner spikes to over 400 milliseconds of error. In contrast, the LLM-ForcedAligner column shows exceptional stability, holding steady at just 25 milliseconds. This proves the method generalizes well, effectively correcting systematic errors instead of just mimicking the training data. Wrapping up, two takeaways stand out. First, reformulating forced alignment as a non-autoregressive slot-filling task effectively eliminates the cumulative drift that typically breaks long-form synchronization. Second, this approach drastically simplifies deployment, replacing fragmented, language-specific tools with a single, unified model that handles 10 languages out of the box. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.